Hello, everybody. My name is Loren Shure, and I'm from MathWorks. I was one of the first people to join MathWorks, so I've been there almost 30 years. And it's been pretty amazing to see the evolution of the amount of data that there is in the world and how people use it. And today I'd like to talk to you about the rise of engineering-driven analytics. And it'll be interesting to see how many of you are trying to incorporate engineering data into your workflows as well. So I'm talking about the rise of engineering-driven analytics, but first I want to tell you a couple stories, short stories. Suppose you're running a factory to produce paper products. You have all these milling machines, and they need maintenance some of the time, but you'd like it to happen at a time that's convenient for you rather than the machine breaking down first. So you want to think about preventive maintenance and how you can predict when something needs help. Another example where you might have engineering sort of driving your solutions is a case of simple heating and cooling in an office building. Somewhere in Australia where it's warm most of the time, you want to start the air conditioner in the morning and have it maybe not quite so strong later in the day. And what people normally do is just have it set on a timer. And it might be nice to have a smarter way to do that. Well, how do you do that? And how do you turn it into a smart system that does things in a really nice way? And another example is having a truck that has on board automatic braking capabilities in case there's some unforeseen incident that occurs and a human might not be able to react in time. Those are all cases where we need the engineering information in our analytics, and perhaps in addition to other kinds of data, to make a good analysis. So I want to first concentrate on what analytics is, and there's a lot of different definitions. I'm going to talk about applying a robust, statistically motivated method to data produced from complex systems in order to understand what has happened in the past and why, to predict what will happen next, and very importantly, make some suggestions or decisions so that we don't have to live with the consequences that the prediction produces right away necessarily. And so if I think about it, data analysis is stuff that's analyzing data that we collected in the past, so it's understanding the past. And what data analytics allows us to do is take that information and then move forward into the future and make predictions and then corrective actions, potentially. Now, when we make decisions, sometimes it is appropriate, and we have people involved in making a decision based on the information produced by our predictions. But in many cases, especially with large amounts of engineering data where we want things to work 24/7, that's not appropriate, and so we want some way of making decisions more automatically. And I'm going to talk about situations both ways where MATLAB and our products get used to help people do this successfully. So we're going from a sort of limited scope of technology in the beginning up to lots of users, lots of data, large scope, and lots of different kinds of technologies that will be involved. Analytics are pervasive. Why now? Why is that happening now? Well, there's three big trends that are happening right now. There's big data, there's compute power, that's not been available before, and there's methods for analyzing the data and coming up with good models for it. So we've got all kinds of data. We've got engineering data, like images and audio, things like that, things we measure off of machines, plus all the business and transactional data that happen, for example, on web e-commerce sites and things like that. We have lots of different potential for computation. We have desktops with multi-cores, GPUs, clusters, cloud computing, Hadoop with Spark capabilities. So we have these in our regular offices now. We have access to a lot of this other information, these other tools, so that it actually makes it possible for us in our own businesses to work on analytics now. And finally, we have had, for many years, many different kinds of machine learning, and then some new kinds that are emerging now that there's more computational power available. And so it's the confluence of these three trends that make analytics so key to what's going on right now. I'm going to give you a quick example first. We have a customer who's got an e-commerce site, and they were making predictions. They've been making models with predictions for a long time based on the transactions they have for a particular user, the keystrokes that's been used, that person has used, the geolocation information, their social profile, what they've looked at in the past. What they've recently added is engineering data, and what they've done is they've taken information from the places where this person is browsed, their customers browsed, and either found out information about the actual data or taken images of it. For example, this one would work well, my guess is for many women, where a black dress is always a good thing. And take information from that, add that to the model, use some image processing in order to improve the performance of the model, improve the prediction so that this customer has a better online experience, is more likely to buy more appropriate things more easily. So let's consider the data and data analytics. There's all kinds of data, and you see I have stuff ranging from what I called before some business data, transactions with the database, let's say, keystrokes and so on, going up to things that I'm going to call engineering data, sensors, images, audio, video, things that engineers connect to and hook up with. And it's a bit arbitrary where that line is, but it kind of makes sense, I think, if you follow my reasoning there. Now, there's an agency in the US called Gartner that does a lot of market research, and so they recently, this year, asked people what kind of data they're using right now for their data analytics. And what you can see is there's a preponderance of business-oriented data and not quite so much use of the engineering data. And then they asked a really great next question: what is your plan for using data in the future? And what you see is a whole lot of engineering data is planned for. So being able to understand, use, and act on engineering data and incorporating it into your model is going to be absolutely key. And this is something that really excites us at MathWorks, because one of the things that we've been very involved in all along is engineering and science data analysis and simulation. Okay, so now the rise of engineering-driven analytics. I want to tell you a little bit more about what the architecture of one of these analytics systems is, because they sort of share a basic architecture. So we somehow have data from instruments and connected systems that we have from the outside world, basically, and it may be coming in through the internet, it may be coming in wirelessly, lots of different data that we've collected. Okay. And then there's also data that we may have data from our business systems, from databases, and basically you can think about a data aggregator that all these data don't need to be physically co-located, but from a point of view from the user, they're sort of in one kind of location. And then we have the data analytics person trying to create models and using machine learning on this ensemble of data. And so this is very, very important and very specific. Now, if this is where it ended, you might as well go home, okay? And why do I say that? Because you haven't shared your model with anyone, you haven't done anything with it, and that's not, you know, maybe sharing your model in certain ways you don't want to do, but you certainly want to share the results at least within your company in some way. How might you do that? Well, what we can do is we can take this predictive model and we can deploy it on the cloud and on business systems very easily with our deployment products at MathWorks. And the and is important here also, and you can also take that same model and deploy it into smart and embedded systems. And we have the tools that let you do both simultaneously, should that make sense. And we've got some customers that actually do both at the same time. If you only want to do one or the other, that's okay, you can. But if you have a need to do both, it's really difficult in some environments. MATLAB makes it possible. So here I said MATLAB and Simulink integrate into the embedded systems and enterprise workflows without you having to do a lot of extra work. We have a lot of the supporting infrastructure there for you. So I want to give an example from Building IQ. This is a company in Australia, very innovative company. And as you can see, they do adaptive building energy management. And so they have lots and lots and lots of data. Okay, so they have every day there's weather that they need to find out about, because their goal here is to make the workplace comfortable in light of all kinds of other information. So one information is what is the demand response for energy? And the demand response is going to be different on a weekday versus weekend, night versus day, and so on. People feel comfortable in different environments, but there's sort of a basic range of temperatures and humidities and things that people are comfortable in. And then there's other things to consider. If you're a business, you don't want to just make it comfortable. You don't want to spend too much money on it, or money you don't need to. So you want to think about not just what the weather's doing, but what energy prices are doing with respect to the weather. So there's all sorts of market information you may need. And so what happens is they take all of this information and they build a MATLAB model with it, with machine learning, and they use some signal processing, because some of what they get in the signals, they extract features. They then apply some optimization techniques to figure out how and where to change the parameters in their heating and cooling system. And all this is happening on secure servers that they have connected to their cloud, so that they get continuous data in and monitoring, and they can continually change what's happening with respect to the temperatures. So let me show you. This is a standard way a lot of office buildings heat or cool things. We're going to do cooling here. You can see we try to put the AC on early enough so that by the time people get in, it's not overly hot. And then at some time shortly after people have left, we turn the AC off and we let it get hot overnight. And then we don't let it get too hot, but we let it get hot up to a certain point. And then we come around the next day and do the same thing again. Of course, weekends are going to be slightly different. What they did was slightly different. You can see they kept the comfort bounds absolutely the same from beginning to end in the workday here. And what they did instead of building IQ is, as I said, with taking in all the other information, what's happening, is it sunny, is it raining, whatever, is they actually started to cool well before they opened. You can see that dip. Now, one of the reasons is energy prices are low then. So if they can get ahead of the curve, they can be at a good point in the beginning of the day. And it turns out people really don't mind if they get a little bit warmer in the middle of the day, as long as they don't get, or colder, as long as they don't get too warm or too cold. And then you can see, well before people leave, they've lifted the restriction about how cold they need to make it, and they let the temperature start to rise. It still keeps the temperature within the comfort zone. So they have this much more complex system for managing the temperature in real time in the building at a 25% cost reduction. So that's pretty good. That's a lot of money when you have a big company. All right, so how did they do this? They have basically a closed-loop system. They have data coming in real time. They have the historical data that they already know, and they know what profile they're trying to, for comfort, they're trying to reach. And so they basically have the data aggregator, and they build their analytical model. And they, as I said, they use system identification. They use control theory to figure out when to turn things on and off. And then they deploy this on a Rackspace cloud server, basically. And the interesting thing is here, they never translate this model that they have into any other language. They run this on the cloud in MATLAB. And they find this is a tremendous advantage, because how many times do they have to do quality assurance? Once, because it's the same model. They don't have to translate it to C, Java, you name any other language you like, and then requalify it. Because if you do translate it to some other language and you don't requalify, you know what's going to happen. Okay, so here's what they said. The toolboxes just worked well together, one of their guys, Borislav, said they could rapidly translate their prototypes into production, and since they could run in real time, they didn't really have to, once they validated it, if it was fast enough, and they were done. And they were able to keep everything in MATLAB. So they really liked the robust numerical algorithms. They were delighted with the reliable mathematical optimization available, and running MATLAB in the cloud in production was just what they needed, so that they didn't need to worry about all the extra costs of translating to another language, requalifying everything, and so on. So here's some of the things that they said. Now, if you're in a building and the temperature gets a little too hot or too cold, you know, life is going to go on. You're going to be okay, probably. Okay. But if you're on the highway and some obstruction comes in front of you on the road unexpectedly, and you're driving really fast, someone could get really badly hurt. So this is not just a small thing, there's safety critical issues here. And so we have another customer, Scania, that has made automatic emergency braking systems by fusing two different kinds of sensors. They have radar, which is really excellent at finding the range to different objects, and then they have a camera, which is really good at determining what kind of object it is. Imagine you have something in front of you, and it ends up being a paper bag blowing across the road. You don't want to emergency brake at that, okay? On the other hand, there are other things that you might want to stop for. Here's a video showing you a truck that's going at a relative speed, 50 kilometers per hour, and you can see the emergency braking stops it right there. Here's another view coming in. You'll see what really happened here. There's a silhouette there of a car that just got put out. Okay, so there's a really strong possibility that a driver wouldn't be able to react quickly enough in order to prevent the collision. And so if you're going to be careful, then you're going to always drive slower. But if you're in trucking and you're trying to get something there quickly, you don't want to have to go below the speed limit. So the question is, what do you do? Well, having an emergency braking system is one piece of helping you get your job done and more safely. So how do they do this? They're using what we call model-based design, which uses another piece of our product line called Simulink. There's MATLAB and Simulink. Simulink helps you model dynamic systems and also helps you deploy them. And what they did is they went around and for months they had sensors in many, many trucks. They collected over 80 terabytes of data in all kinds of different situations, and they built a model with it. And in that model, they were able to incorporate that model for the analytics about when is something dangerous, when it's not, what does it look like, and so on, the fusion. And they can incorporate that into their whole model-based design situation that knows when and where to do the automatic braking because of the detection that it's a real threat. And they were able to do that. So we have, as I said, 80 terabytes of data from the vehicle logs. They have all the data from there. They then go to use machine learning, and they're able to take that information, and then they built a little controller that they embed in the truck, and the truck actually has this set of, hooked to the sensors, it has the ability to actually enact the automatic braking. So it gets the information in real time, it has the model, it knows what's going to trigger when they need to do the automatic braking, and it just does it there. Now, while it's doing it, of course, it's collecting more data. So what's happening is Scania is able to update and refine this model over time and maybe make better embedded devices over time as well. Okay, so now I want to talk a little bit more about the analytics piece, because I think that many of us, when we went to university, we studied physics, or we studied EE, or we studied all kinds of different things, but we didn't necessarily study analytics. And yet, here we are talking about a lot of analytics, and we have to talk about it because there's things like 80 terabytes of data lying around that we need to deal with. Okay, where do we find it? Well, in our customer base, we find it a lot in automotive, off-highway vehicles, aeronautics. If you can think of any NASA space mission in the past 20 years, there has been some automatically generated code from MATLAB or Simulink in all of them, doing some really cool stuff. But you also hear it, you just heard me tell a retail story. These are places where people have not necessarily traditionally used all kinds of advanced computing. Finance has been doing a lot of advanced computing for a long time, but it didn't always do very sophisticated stuff. It's very sophisticated now. Healthcare management, internet, those are all places where a lot of interesting analytics are going on. And then there's emerging markets, or more emerging, industrial automation, clean energy, medical devices, and so on. So we're finding that it doesn't matter where we look, there's analytics that people have to use in different parts of each one of these situations. My next example is Mondi. Mondi is an interesting multinational corporation. They manufacture machines that make paper and other kinds of polymers. And they gather a whole lot of data. They gather sensor data that they have on these machines. They have 10 to 100 sensors on each machine gathering data every minute. And then there's another measure that happens about every 40 minutes that tells them the quality state. Is the machine in good shape or not right now? And they, in a room, have hundreds of these machines. Okay, so they came to us and they wanted some help. And they said, how can we do something to see when we could predict when we're going to need the maintenance so that we don't let something break at a bad time? Maybe we can fix it beforehand, or maybe we know we can wait just until a certain point and then we'll go and fix it at a time more convenient for us. So what we did is we worked with them, and what they did is they chose to try a whole bunch of different classification techniques using statistics, machine learning, and neural networks. And then they chose the one that described their machine situations best, and they were able to then do something very cool. They wrote an application with our help again that they deployed onto the machine floor to people who are not MATLAB users, and they're not number crunching kind of people mostly. These are the people, the machinists and the machine operators, who know a lot about the care and feeding of these machines, and they know how to keep them healthy and running well. And what they have now is they have a screen that if you click on any one of these options down the left-hand side, it'll show you a machine, and it'll show you different traces of the sensors, and it'll tell you from the state of the machine whether it's healthy or not, and sort of how badly it got there, what parts are going badly. And you can see another one where things are going well. So what they can do is they can come here to this application, and they can say, oh, it looks like, you know, one machine is doing poorly, and we're going to need to do something soon, but it only has 4 more minutes that we need to run it right now. I think we can make it 4 more minutes, or not, you know, depending on what the situation is. So this is just another piece of valuable thing where a person now steps in and uses their judgment about how to time things well for their best outcome. So that's a case where we don't have the automated decision like we had with the Scania case with the automatic braking. Here we have a person in the loop who's going to help decide, based on that information, what am I going to do now? So I've just talked to you about 3 different situations. We talked about retail. I talked about the heating and cooling system. I talked about the 4, I guess, the automatic braking, and I talked about the Mondi system. And so I want to show you a little bit about what's happening here is we have this person in the middle, right, who needs to do this data analytics. Well, who's that person, and what do they need to know? A lot. Okay, they need to know a lot, and this has been a real problem for everyone. They need to be a domain expert in whatever domain you're talking about, whether it's image processing or manufacturing of some sort or automatic braking, whatever. They need to know how to do coding and integrate some code into some other piece of infrastructure there, okay? And they need to know how to do statistical and mathematical modeling. Now, it's very, very difficult to find people who can do all these 3 things. And so one thing that you hear is that in all the media, we have this major shortage of data scientists, and maybe not here in this building today, but in general, at a lot of places, there's really not nearly enough capability as people need. And so what they say is what we need to do is we need to expand university programs and train existing analysts. And that's true. Both are true, I think. And I want to convince you of several things here. First, I want to tell you what we're doing with respect to universities. So we have sort of a 3-pronged approach there. What we have is a program at MathWorks that allows people who are trying to make a MOOC, a massively open online course, using MATLAB. We try to make sure we give them resources so that they and their students have access to MATLAB and any of the tools they may need while they're learning and getting their skills up. So here we have an example of 5 different courses that we've helped fund, if you will, based on some of the open platforms there. And so there's a lot of people here, you know, with MOOCs, there's, you know, probably tens of thousands, maybe even hundreds of thousands who are getting trained here to be able to know more about machine learning than they've ever done before. And as I said, if any of you are ever thinking of creating a MOOC, please contact us at mathrix.es. We can definitely figure out how to help you in terms of some of that infrastructure stuff and if you're using to get MATLAB available for people. Okay, so the next thing, and this is particularly for students, but the next thing is data. Where does data come from? Students don't just come knowing where to get data. And so there's this really interesting thing that we've been doing, investing in a platform basically for students and makers called ThingSpeak, and it's an IoT open platform. And please come to our booth and ask anything about it or go to our website. It's basically an open data platform for Internet of Things, and I'm going to explain just a couple little things we've done with it. So what you have behind it is MATLAB on the web, essentially, helping you do some of the analysis, and other MATLAB products like Simulink. And with MATLAB and Simulink, we've had a lot of support for a long time for low-cost hardware. An example here is Raspberry Pi. And so what we've done is we've hooked up a camera with a Raspberry Pi at our headquarters office just outside Boston, Massachusetts, and we have it trained on the big road in front of our office. And it counts cars going east and cars going west as a function of time. So it takes an image for, every, I don't know how many seconds, but it takes them and starts counting them, uses image processing techniques to find cars and count them. And so what you see here is we took one day in July, and you can find there were peaks during the day at various hours. I have no idea what was happening at 6:30 in the morning. That's when I'm on my bicycle, but I don't know what other people are doing then. But you can see a peak near 6:30 and 7 o'clock. Maybe it's movie theaters coming in and out. I don't know. So, but we allow you to automatically identify the peaks. Here you see the volume of traffic for the entire week. And you can see in blue the westbound traffic, and then green, orange the eastbound traffic. Now, you haven't had a chance to look at this data in much depth, but actually it is possible to tell from this which days are the weekends. And it turns out whoops, I went backwards, sorry. It's the first two. And the reason we can tell that partly, without just looking at the calendar, is if you look at the traffic near noontime or in the middle of the day, it's not much reduced. Whereas on the weekdays, people are in at work. So if you look at 7:29, there's a peak in the morning and a peak in the late afternoon, but there's sort of more of a lull in between. Weekend days, there's tons of shopping malls near there, so everyone's chaotically going everywhere, which way. And so we did this just using Simulink Raspberry Pi and some computer vision algorithms to understand what was going on, collect the data, and then be able to make plots like these. Okay, and the third thing is we've been trying to facilitate the interaction between industry and universities. And this is something that industry has asked for a long time, and I think universities also very much like it. One of the reasons industry cares is they want to make sure that universities are producing students who have the right skill set so that they can go and get jobs at their company. So what happened here is National Tsinghua University in Taiwan teamed up with TSMC, which is a very big chip manufacturer in the world. And the students were given some process control data, and they were asked to please improve the semiconductor yields. So they were actually given access to real company data, and they were told about what the process was so far. And what you can see here is the original distribution had much fewer good chips per unit time, and the variability in the goodness of the chips was really very spread out. And what they wanted to do at TSMC is have a much higher capacity of good chips come through and a variance reduction in terms of how reliable they were. So they wanted to throw out far fewer chips than they were throwing out. And so what they did is they signed up a bunch of teams. There were 21 teams. These teams had access to the data on a Hadoop file system. So they immediately had to think about how they were going to access that in parallel. We were happy if people wanted to use MATLAB. We were willing to give them licenses so that they could do it. Turns out, as I said, the data's in Hadoop. The winning team and team number 2 both used MATLAB for their solutions. Okay, so we were very, very happy about that and glad for them too. So MATLAB was really up to the task there with some really good smart people behind it. at the university. And of course, TSMC's got something really, really valuable out of this. They figured out what part of their processes needed to be fixed and how to patch them. Okay, so MATLAB actually lets you be your own data scientist, and I'm going to try to explain a little bit why, because maybe we don't come out, again, this might not be the conference where you think about that so much, but a lot of places, people are asked to do this sort of analysis, and that may not be their first core capability. And so one of the reasons that we say that this is, MATLAB is really good for being a data scientist is at MATLAB, at MathWorks, we're very much an engineering-driven company. So I've been at MathWorks for almost 30 years. I was the first person hired. I'm still there. So that says something good about it. Lucas has been there for quite a long time, too. And we've helped design the product. We know if we were out in industry, we know what we would want and what would make our lives easier. And so it's designed by engineers and scientists for engineers and scientists to use. So it's not trying to be pedagogical in terms of making sure everything looks from a computer science point of view perfect. That's not the right audience for us. Okay, and why do I say all of this? Well, there's the 3 trends that I told you about, and I want to tell you a little bit about what's going on in MATLAB recently for all of these topics. So in terms of big data, we have native support for lots of engineering data. We've had that forever. And more recently, we've added something called a data store that can sort of make your data into an abstraction and just deal with all of it without you having to sort of loop through and find it all yourself. And just recently, we introduced something called a timetable and tall arrays. And tall arrays are really, really amazing. They are appropriate for data that does not fit in the core of one machine and be able to work all at once in MATLAB. And it's partly because it helps you deal with the data. It's also able to take advantage of whatever compute power you have available to it, either your desktop or whether it's multi-core GPU, MATLAB on a server, MATLAB on the web, MATLAB production server, MATLAB in the cloud, and Hadoop with Spark support, which got introduced in the most recent release as well. And finally, there's all the machine learning capabilities that have been around for a long time. There's something called the Classification Learner app. We've been making apps because we know that we didn't know how to do all these things 10 years ago or 5 years ago. How did we learn? Well, we learned by bugging the statistics people at our group, but that's not scalable. So what they did is they tried to write an application that would make it more possible for more people to approach how to work with the different kinds of modeling. And then more recently, we introduced CNNs, convolutional neural nets, for deep learning in our 2016A. That was earlier this year. And in our 2016B, we added support for RCNNs and also the tall tables and tall arrays can be used for creating your machine learning models. So the tall arrays, the models can now be used with really big data sets, and they've been appropriately written so that they understand how to get in chunks of data at a time and work on it. So I'm going to give you a brief view. Here's the Classification Learner app, and what you do is you basically choose a data set, and I'm going to not show you every last piece of this video here because it goes slow. And I'm not patient. Okay, so we load in some data, step 1, makes sense. And the next thing we want to do is we want to start choosing some different kinds of machine learning modeling. So we're going to choose several different kinds of models. And I'm going to skip through some of that. Once we choose the models, we have to say which model's best. And there's some support for that. There's something, for example, called confusion matrices that help you tell how much of the variance of the data is explained by the model. And you can pick the one that makes sense. Once you've chosen one that you like, you can come and export the model. And by export the model, what that means is it generally is a likelihood that you're going to generate code from it. So you're going to end up doing this process manually once or maybe 3 times or whatever, but then you're going to end up with a model that you can put into production that doesn't need you in the middle of the loop there. Okay, now that was just one example of a MATLAB app. We have something like 70 or 80 other apps across all of our different product line here, and it really depends what kind of data you have. If you have signals, we have some apps that help you with signals. If you have wavelets and analysis you want to do with them, they're really good for pulling out features, by the way. That might be something that you could use. We have neural nets, a bunch of image processing apps, all kinds of different apps that are going to help you. And you don't necessarily need to be an expert in any one of these areas. You just have to have the appropriate kind of data, and you will learn as you go what kind of models you can make. So it actually lets us as scientists learn and explore and find a model that works. And I'll tell you what I do. When I do this sometimes, and if I'm trying models that I don't know much about, I wait and see if the model's any good, and if I get a model from some kind of modeling that I've never tried before, I then go to the documentation and I read all about it. But I don't do it beforehand because I don't need to. I can just try it first, and then it may be worth me learning more about because it's something I want to use. And if I'm going to use it, I sure want to understand it and be able to explain and defend it. And so you can do that based on the documentation. If you want to create your own application for other people to use, we also introduced something called the App Designer. And this is a new and much updated environment for building applications and GUIs in MATLAB. And it's really nice. On top of that, there's more choices for the kinds of widgets, if you will, that you can put in. So there's dials and gauges that you can put in to run your application. So the person who's running it, they could have a screen that looks very familiar to them without needing to know what's happening in detail under the hood there. I talked about deep learning just a little bit. We have deep learning available in the Neural Network Toolbox, and I want to show you a little bit of video. We took this video in the winter last year at the entrance of our corporate headquarters, and we already had we trained the model. This is a trained model running right now. But the model was basically looked at a whole bunch of traffic for a long time, and it had in it some identified trucks, vans, cars, sports cars, different kinds of vehicles. And now we're running the model as what you can see. This is kind of complicated. What's happening is the algorithm is using the camera. It's identifying when it thinks it sees some vehicle, and once it sees the vehicle, it then tries to give probabilities about what kind of vehicle it thinks it is, whether it's a minivan, a minibus, a sports car, convertible, and so on. And if I'm not mistaken, pretty soon you'll see my favorite little piece. You see this little orange that's coming along there? That's my intrepid friend riding his bike in the winter. We never trained it with a bike, so it never says bike over there. But he rides his bike pretty much every day. So here are a few frames where you can see from the video I just showed you where it identified vehicles and got their designation correctly. Okay. The final example I want to talk about is from a startup company called Closedloop. And it's the first consumer otoscope, so for looking in ears, in a mobile device, and it uses machine learning and computer vision, and it happens to use some of the processing power of the iPhone or Android or whatever, and also it's using information from the cloud. And the thing that's really nice about this, and I'm going to start the video now, is you can have this in the hands of a professional who maybe isn't a physician, though, who can take the video, send it to the cloud, put in all the information after they're done recording it, and then compare the video with this large database that they have that's done some training saying, oh, you just need to make the kid have a nap, or give them some Tylenol, or whatever it is. Or you need to make sure this child sees a physician right away. They might need some medication, some stronger medication. So it makes available something in a much more broad way than could be had otherwise, and for fairly low cost that way. So whether you are thinking about having data analytics be part of your workflow as a small company, at a university, a startup, a well-established company doing things that you've done before but you want to automate, or doing things that are absolutely brand new, I think MATLAB and our products make it possible for you to become the data scientist. And I hope you'll stop by our booth to see more. Thank you.